Hey there. We're looking at the second day of 8.1.2, and as always, just kind of go through, fast forward if you need to get to a certain spot, or you can always go back and rewatch the video if that helps you. Don't feel like you have to watch every second of the video. Do what's most important for you, but don't try to cheat yourself on stuff. Make sure that you're getting all the material that you can. I'm going to jump to the fourth page in here. I showed it at the last 8.1.2 day one. Just those those measures of central tendency, right? We talked about mean and we did talk about median. And mean, remember, is all those values added up divided by the number or the amount of values to find an average. We use that example in 8.1 about everybody having so many people in their family, that census problem, and then we share all of those boxes or those cubes out as evenly as possible. That's an average, right? Median is when arranged in order. Cannot emphasize that enough. Then find the middle number, right? So the middle number in this case is 15 because it's all put in order there. Okay, so just a reminder on those two great vocabulary words that you should know: mean and median. Okay, and they are measures of central tendency. So jumping up here, I did put a note right at the top that you should look back at 8.1.2's previous problems to kind of help you with some of this. For you to remind yourself of what they were. So even though there's outliers in the data, the mean and median in 2009 are almost the same, right? Well, I have the mean and median sitting in front of me for 2009, and that mean and median, the mean was 2009, 225, I gotta erase that. Why is this not working? There we go. 205. It was about 225.1. That's an approximation. The median was 225, so they were very close to each other, right? So now the question is why? Especially with those outliers. Well, if you recall, the small outlier in this case was 185.25, and the large one was 252. And when you have a large one and you have a small one, they balance each other out. So the two outliers balanced each other. Because if you remember in the very last problem, 8-14F, I think it was, the median is usually a better choice when you have an outlier, because what it does is it usually is a better representation of all the values. The downside, the mean then usually becomes what we call skewed, meaning it's very one-directional and isn't usually a great representation. But because I have two of them in here, they balance each other. So in 8-16, what if the 8th place jump was 222 instead? Well, this is where what we're doing is we are kind of eliminating, right? We're kind of eliminating that outlier. The 222 starts to become what we call normal, and then we have just one outlier, that 252, right? So now all of a sudden we expect, since we're eliminating 185 and we're bringing it up to 222, then it would be kind of like the median and the median would stay up about the same, right? Stay the same. This is where I got this confused in the end of the last problem. Median would stay the same, but the mean would definitely get larger, right? If you eliminate 185 and you increase that. So there's first thing, right? we're making our prediction. And I think it's important to kind of make a prediction, because what it's doing is it's forcing you to think about the problem before you actually just do some calculations. Now, if we actually do those calculations, the median would stay the same because I'd only eliminate the small number. The mean, on the other hand, when I add up all those numbers, I get 1,837.5. I still have just 8 values because I eliminated the bottom one, added the new one, and then when I divide that, I get 229.6875. Now remember, our previous one up here was 225.1. Notice now that that larger outlier, that 252, now it really skews the data, right? When the median is 225, that's going to be a much better representation. Let me see if I've answered all of that question. Test your prediction, yep. So Efron has been keeping data on the Calaveras County frog jumping contest for several years. Look carefully at the stem and leaf plot he made for the top 8 jumpers in 2007, showed to the right. What's the minimum or the smallest value? Oh, these stem and leaf plots, right? The minimum is, we take a look and let's just remember what these numbers are here, right? This, if I'm looking here, that's going to be 221. Then I have a 222, right? Then I have a 225. And then I have a 228. Okay, so remember now how that hopefully goes. Then a 234. 238, a 245, and a 256. Okay. Hopefully that helps us just kind of remember all of that. To find the minimum or smallest value, oops, bumped that, sorry. That's going to be that 221. And to find the maximum or largest value, that's going to be the 256. Okay. Are there outliers in that data? Let's take a look at that. Well, if we look at the bottom, the low end, that 221, well, there's a 222, a 225. That doesn't really look like much of an outlier. Let's look at the big one, 256. Is it really far away? Nah, not really. It's not like, if you could think about our histogram in 8.1.2 day 2, that histogram, remember, there are big gaps in between there, right? And in this case, it's not super far away. So are there any outliers? I'd say not really. Most of the data is near each other. And those are using not good mathematical terms, but they're using terms that we understand right now as 6th graders being introduced to this. Is it possible to find the median of the data in the stem and leaf plot? If so, find the median. If not, explain why not. Well, let's jump back up and see if we can. Actually, I kept this bigger version here for that. Of the exact same thing. And I'm just going to jump right into D. Is it possible to find the mean of the stem and leaf plot? If so, calculate and explain the mean. Tells you about the frog jumps. Okay. So I really left this much larger version here so that we could take a good look at it. Or this version right down here so we could take a look. So median and mean. And the answer to that is yes, of course we can calculate both of those. Why? Because we have all of the values sitting there in front of us, right? We can do we can do that. I'm going to actually jump to D, the mean, first. And then I'm going to jump back to the median because I'm going to have to do a bunch of crossing off and I don't want to make stuff too messy. So we already know our numbers from right here for our mean. We add up all those numbers, right? And when we add up all those numbers, we get 1,869. We have 1, 2, 3, 4, 5, 6, 7, 8 of those values. So we divide by 8. And then we would get 233.625. So that's our mean for that one, right? Let's jump now to median. Remember, with our median has to be in order. Let's check our data. Of course it's in order, isn't it? And then number 2, we've got to find that middle number then. Right. So this is why I waited on here, because I'm going to cross stuff off. What I'm going to do is I'm going to put my focus on just the leaf part of it, because the stems, the leaf, are what distinguish and make unique numbers. For example, this is just 221. Then I'm using this 22 again for this 2. So what I'm going to do is I'm going to find the middle of the leaf parts, and that's all of this side, right? This is the stem. These are the leaves. All right, so I'll since I'm working to find the middle number, I'll cross off the smallest, and I'll cross off the largest. Cross off the next smallest and the next largest. Next smallest, next largest. It's tricky sometimes when you're going through this, because sometimes you're going to want to accidentally cross off the wrong number. Like when I was doing that 238, I might have accidentally wanted to do 234. Alright, so I have 2 numbers left. When you have 2 numbers left, you got to just find the average of those. Alright, so what I have now is I have 228, and I have 234. Okay, so I gotta find the middle of those 2 numbers. Now, actually, you could just figure out the middle of the numbers by looking at them and know that it'll be 231, but let's find that it's just, we could do 228 plus 234 divided by 2. What we're doing is, again, finding the average of those. And when we add that all up, we should get 462 divided by 2, which will be 231. Okay. Which represents a typical jump for 2007 better, the mean or median? Well, let's take a look. All right, let's take a look. Whoops. At these. So here's 233 and here's 231. Let's take a look at which one seems to fit better, right? Well, 233. Let's do this instead. 233.6, right? That would fall right around here. Okay. The 231 is just slightly smaller, right? I don't even have room for that. Slightly smaller than that one. Could you say one of them really is better than the other? Not a ton, but I would think that you could say that the median is a slightly better choice. Now, the reason the median is a slightly better choice is because we have 4 different values in 222, and then we get 2, and then we have 1 value, and then we have 1 value, meaning it's not really outliers, but we kind of have more values pushed away, further away in the 220 or the 24 stem and the 25 stem. So in this case, I would say the median, but not much. It is better. You know what I'm going to say? Slightly better. It is better, but it's not spectacularly better. Create a new stem and leaf pot for 2006. What is a typical jump for 2006? So key part is let's create those stems. I notice that it starts with a 20 and ends with a 23. So I'm going to do 20, 21, 22, 23. Then we're going to go through and we'll start at the smallest here. Notice there's a 4 as our last number. Then I've got a 5. Then I have an 8. Then I've got a 9. Now we're jumping into the next category. It's a 2. Another 2. 222, that means we jump into the next category, and then 235. There we go. Looks a lot like our previous one, doesn't it? 2007 data. In here, the mean, if we add up all our numbers, we get 1,707. Ooh, that's smaller than our previous one, I think, isn't it? 8. And we divide that by 8, I should say, and we get 213.375. And then the median, again, just because I find that students have problems with medians, I could do the medians in both of them here. So I could go like this, this, right? And we're working our way to the middle, and we have 2 of them. So the median is 212 plus 209, sorry about that, divided by 2. And when you do, when you add those up, you get 400 and, oops, sorry, I just drew blank there, 421 divided by 2, which is, I'm going to run out of room here, 210.5. If you're doing it in the stem and leaf plot, you would again cross those off, smallest number, biggest number, next smallest number, next biggest number, next smallest number, next biggest number. So there's that 209, there's the 212. Okay. You could stop at this point. The additional problem is a visitor to the frog jumping contest told stories about another contest he attended. He made the statements below. Find the possible sets of data that would satisfy all these statements. The measures of the jumps of 7 frogs were all integers and had a median of 14 meters. So we have 7 frogs. 1, 2, 3, 4, 5, 6, 7. The median is 14, so our middle number has to be 14. The minimum jump length was 11, and the maximum was 15. The value of 11 appears more often than any other value. So this one, I did this one. I was like, oh man, now what? Well, if we look over here, the only 2 numbers that can be here and here could be 14 and 15, right? That's it. If we choose 15 for this one has to be 15. If we choose 14 here, this could be 14 or 15. Okay. So now if I jump over here, I have to have more 11s than any other value. Well, if I make this one, let's say I make this 14 and 14, right? I need to have more 11s than anything else. So I'd have to make this 11 and 11. I couldn't make it 12 and 13, right? And actually, it doesn't work. It doesn't work because I have just as many 14s as I have 11s. So even if I had said, okay, and I know that you guys probably see that this can't be 15 and 15 because I have the same problem, right? So what I recognize is that this has to be 14 and that has to be 15. And there's no way that this could be 12 or 13 because I need to have more 11s than the other ones. Okay? So that's actually the only way it could be. I encourage you to do something like this in the learning log. The mean and median are different ways to describe the center value. Write a learning log entry. So just take some space and write a little bit. Describe how do you find the mean and median for a set of data. Be sure to include an example. How do you find the median if there's an even number? Well, we've been doing a ton of those. If a data set includes an outlier, which measure best describes the middle? Title this entry mean and median. We've been talking a ton about it. I think this is a great idea for you to do this, just to kind of like get some of your thoughts out, right? You could give a small example of how to find those mean and medians, right? Make your own example, 1, 1, 2, 2, right? Something like that. Be sure to include example, how do you find the median if there's an even number? That's what we've been doing, 8 jumps, right? If we have 1, 1, 2, 2, and then we have a middle number, right? So the middle number, it's okay. And then we have 2 middle numbers here. We got to find the middle. It's 1.5, right? Finn, you need to turn that off. And then what else? If the data set includes an outlier, what's best describes? That's the median, right? Oh, now we're having a breakdown. There's your answers. Answers here shortly. Just a reminder, make sure you show your work, right? That's how I know that you did that. I did put, if you look in the ebook, these I already put in order for you to help you out because I wanted to make your job easier when you do that. Okay? Let me know if you have any other questions.